The sun is so much bigger than Earth that two parallel lines from the top and bottom of Earth will hit sun very near the center. This is the hypothetical and simplified situation when Bill and Jane will be lying on the surface and looking perfectly horizontal. In this case, the math is actually much simpler than drawing. It's just radius of the sun minus radius of the Earth divided by radius of the sun, or 99.1%. So both will see 99.1% of their half of the sun. If the sun is over 100 times wider than the Earth, those two horizontal lines are less than 1% of the sun's width apart, almost indistinguishable. So is that your argument? Since the two people's view of the center of the sun could be 1% of the sun's width apart, almost indistinguishable, the Earth must be flat? You see what Harry and Michael have done here, right? First, they have accepted the completely unsubstantiated claim that the sun is 100 times larger than the Earth as a fact. But worse, they have applied that huge sun to Bill and Jane's sunset, as described by esteemed astronomer Nick Loam. Their argument is basically, okay, Mike, Bill and Jane can't actually see a full 50% of the sun at the same time like Nick said, but they can see 49% of it since the sun's 100 times bigger than the Earth, and therefore the tiny Earth would only block 1% of their 50% view. So basically, Bill is seeing this 49% of the sun, and Jane is seeing this 49% of the sun at the same time. They can't see the blacked out line through the sun because they can't see around the Earth, but only horizontally from their spots on the top and bottom of it. Here's what it looks like from the side. Bill can see the blue line and above, while Jane can see the pink line and below. Neither of them can see the black 1% of the sun. The obvious problem is that nobody has ever sat on this tiny Earth and seen this monstrosity of a sun fill their entire field of view as it rose or set. We see this, not this. It seems Harry and James have completely forgotten about perspective. We don't see the sun 100 times larger than the Earth, or even twice as big. Heck, we don't even see it the same size as the Earth, to where we could see the entire horizon aglow with the sun's corona as it rises or sets. And nope, we don't see it a quarter of the size of the Earth like they tell us the moon is either. We see the sun as 229 times smaller than the Earth. The sun, as we see it, has an angular size of half a degree. So it would take a chain of 720 suns side by side to stretch the 360-degree circumference of the Earth. And 720 suns divided by pi makes 229 side-by-side suns to stretch the entire diameter of the Earth. So if we go back to this image and make the sun the Earth, the size of the sun as we see it in the sky is about halfway between the size of that little Earth and the size of that tiny moon. Let's see how that looks with our tiny sun off to the side of our huge Earth. So here's our Earth with half of it lit by our sun, which is not scaled to distance, but is finally scaled to the correct angular size for once. And now we can put Bill and Jane on opposite sides of the Terminator line and show their parallel, horizontal lines of sight as Bill looks west to see the sun set on his horizon, and Jane simultaneously looks east to see the sun rise on her horizon. So are they each still seeing all but 1% of their half of the sun? Of course not. If the heliocentric model aligned with reality and had us seeing a sun with half a degree angular size as we do in real life, then the actual sun would be 115 sun diameters from Bill's horizon and 115 sun diameters from Jane's horizon as they simultaneously saw it set and rise. How in the world did we ever get sucked into believing that we had to always consider the sun as some huge 100 times bigger than Earth light that people can see from both sides of the ball Earth at the same time? The idea is absolutely ridiculous when you stop and think about it. Let me give you another real-world example. Let's imagine Bill and Jane are strapped to the top and bottom of this Sky Chef's container. Bill can only see what's above the container, and Jane can only see things that are below it, because the physical structure of the container is their horizon. Let's say the center of the container is directly aligned with the center of the much larger airplane. Bill and Jane can both see their own half of the airplane minus the width of the container itself, which they cannot see around. With me so far? Okay, now I'm going to retain the size of the container, since it doesn't change for Bill and Jane as long as they're in the same proximity to it. But I'm going to move the much larger airplane many miles from them, although keeping it centered on the container, like it was before. So are Bill and Jane still able to see all of the airplane except for the center, like before? Of course not. Neither one of them can see any of that plane at all anymore. But wait, Mike, they must be able to see it because it's still much larger than the container they're on. Sorry, Charlie. Their horizontal lines remain the same parallel distance from each other and will never converge no matter how far away we move that plane. But the angular size of the plane will keep diminishing with distance, even till it gets down to a half a degree, which I can't even show you on this scale because you wouldn't see it. People, we have been duped all this time. Even if we accept, for argument's sake, that the sun is 100 times larger than the Earth, its angular size is 229 times smaller than the Earth. And so the orange ball we see setting is 229 times smaller than the Earth we watch it set from, despite any actual size you want to attribute to each object. And just like Bill and Jane couldn't see this plane, which is actually much larger than their container, but appears 6 times smaller due to perspective, we couldn't possibly see the sun from the top and or bottom of our Earth at many times smaller than this plane is to this container.